we're going to evaluate the integral of inverse tangent of square root of x. First we'll make a substitution. Let y equal to square root of x, so that y squared is equal to x and dx is equal to 2y dy. And let's rewrite the integral by changing the variables from x to y. This will become the integral of inverse tangent of y times 2y dy. We're going to use integration by parts. Integration by parts formula is the integral of u dv equals u times v minus the integral of a v du. So this integral, inverse tangent of y times 2y dy, we'll call this the integral of u dv, and we have to make a selection for u and for dv. Let u be inverse tangent of y. It's because it's a lot easier to differentiate inverse tangent of y than to integrate it, and that leaves dv to be 2y dy. And now let's find the other two parts, that is du and v. Du is equal to 1 divided by 1 plus y squared dy. Now v, normally we would let v be y squared because the derivative of y squared is 2y. But because we have to multiply v by du, we see that if we add 1, it will make the second integral a lot easier to evaluate. We are allowed to add any constant that we want because the derivative of y squared plus 1 will also be 2y. Now with this, the second integral will become trivial, and so the integral of inverse tangent of y times 2y dy with the selection of u, v, du, and dv becomes u times v, that is y squared plus 1 times inverse tangent of y minus the integral of v du, and the integral of v du is just 1 because y squared plus 1 divided by 1 plus y squared is 1. And so the integral on the right is extremely easy to evaluate. And now we're almost done. We have the integral of inverse tangent of y times 2y dy is equal to, first we have y squared times inverse tangent of y plus 1 times inverse tangent of y, which is inverse tangent of y, and then minus the integral of 1 with respect to y, which is y, and then we add a constant c. But recall the original problem, the original integral was with variable x, so that's what we have to leave our answer in variable x. We had the integral of inverse tangent of square root of x dx, and recall that y was equal to square root of x. So now the answer is y squared, which is x, times inverse tangent of y, that's inverse tangent of square root of x, plus inverse tangent of y, which is inverse tangent of square root of x, minus y, which is minus square root of x, plus c. And that is the final answer.